All right. So in class, we talked about 10.1. So again, 10.1 is more of like the background with fresh water. So again, we talked about surface water, polar regions, groundwater, basic statistics about how much of the water supply is actually available to us. And again, what we do with those different water sources. Again, how much of our water footprint is. Again, we did this activity the first day of class, so again, we should be very familiar. Pretty much understanding that we do have what could be a freshwater source. So today we're going to be talking about how we can increase these freshwater supplies. So the first thing is that groundwater for food production and for use by cities is being pumped by aquifers faster than it can be replenished by nature. And the whole idea is that these aquifers are kind of like reserves. They're kind of like an extra gas tank, but, or I guess like an extra water tank. And so we can't refill that tank because we keep continuing to use and use and use it. And so that's one way in which, it's not really good. We're not being too renewable with that. The dam and reservoir systems and water transfer projects do expand water distribution, but what we also see is that they also disrupt ecosystems and displace people. So again, you got to get the water source somewhere. You got to stop the connection from somewhere. So by building these dams and reservoirs, what we're seeing is that we're actually changing the environment, which again, we don't want to do. We want to kind of keep nature as it is. But there is that option to be like, well, there's a lot of seawater. Why don't we change that into fresh drinking water? And the process is desalination, but at the same time, that's very expensive. You got the money to do it, go for it, but we can't continue to do it. So the idea is that aquifers are being used faster than they are replenishing. So again, because of the irrigation systems, because of our agriculture, over pumping is going to limit food production. Again, raises food prices, widens the gap between the rich and the poor. So again, there's an economic uh, factor in this. But the thing is that a higher demand of food because of these water shortages is why there can be that difference, right? People can afford the food, they'll get it, but if not, then they'll sell it for something else. As water tables drop, water must be pumped from lower depths. So again, the lower we go, the more energy and costs it takes to get lower and lower and lower just to get that water. And this is not a good thing because what can happen is this can cause subsidence and sinkhole development where the land above aquifers collapse. So again, think of it as like the water is keeping us above ground, depending on where you're at. And you take that water away, there's a lot of empty space underneath. You could collapse, right? Um, and if it does collapse, any water that could have been in there is not going to go in there. You can draw salt water into fresh aquifers too with over pumping. So by creating that, you're going to see that all the different minerals around can seep into the fresh water. And so again, you get enough salts in there, water is going to be undrinkable, unusable for irrigation. So again, sometimes we may stab ourselves in the foot with different things that we use. So if we think about this water for here, obviously you got a lake, you got an aquifer, again, underneath the land, might be a layer of clay, but then here's some combined aquifer. Now, we can do some artisan well to get water to come up, but again, anything goes wrong here, this whole aquifer is gone. If this were to collapse, if some of this were to collapse. And again, we're just taking it faster than it can replenish. And again, this is the fresh water that we're talking about. If we're looking at aquifer depletions, if we look anywhere around this Dust Belt area, again, we're using too much in this area. And what we see is that water is being taken out too much in northern Texas, western Oklahoma, and then western Kansas. And because of that, again, we're just taking too much. If you look at the Midwest here with Wisconsin, Illinois, and all that, again, we have Lake Michigan and we have the different Great Lakes, but eastern part of Illinois, so Chicago area, western parts, so Gary, Indiana, again, we're taking too much. Again, if you look at Green Bay area here, taking too much. But you see more in the south than south or west, southwest, we're taking a lot of it. Watch that video later. All right, so the second one was dams and water transfer products. Now, there are advantages and disadvantages for both these large dams and water transfer projects. Dam and reservoir systems capture and store surface runoff from a river's watershed. So, again, water is released as needed to control upstream flooding, generate electricity. So, again, hydropower from that, supply fresh water, and provide recreational opportunities. We also see that water transfer projects use dams, pumps, and aqueducts to transfer water from water-rich to water-poor regions. So again, it allows for different areas to get the water that they need. There are disadvantages, though. Dam and reservoir systems displace millions of people, flood productive lands, impair the ecosystem services of rivers, and have a useful life expectancy of only 50 years. So, the idea is that again, we're changing the way in which water is flowing, essentially, right? So, again, you're getting more water in one area than it might support, so it might flood. You're taking away more water from a region. So, an area that depended on the heavy flow of water, that water flow is going to lessen because of that dam being there. And if there's less water flowing through it, there's a chance it might dry up. And so, those are a few things. I know that different migratory fish, like salmon, that have paths for reproduction for mating season, they might die because of these large dams unless they have adapted to the situation and created dams that are eco-friendly. But again, you got a lot of different ways. Water transfer projects are going to reduce the river's flow in Flush and Axon. This could lead to pollution. So again, if you think about Lake Michigan, very dirty place, very disgusting. But what helps is that there's a lot of water in that lake, so it can kind of break up any type of pollution that does go in there. But with less water to dissolve the pollution. So again, you would have more pollution in there. Threatened fisheries, again, we kind of talked about that before with salmon and the flow of fish. Artificially cheap and costly, leading to inefficient and wasteful water use. So again, sometimes the cheapest way isn't the best way. And that's what we see with some of these water transfer projects. Removing salt from seawater, again, this is a idea. So this process is called desalination. Distillation, so 0.3% of the world's demand. What essentially happens is that you're heating salt water until it evaporates, leaving the salt behind and then cooling and condensing water vapor into a liquid water. So again, you're trapping the water vapor into a separate thing and letting the salt dissolve. There's also reverse osmosis, and this uses high pressure to force salt water through a membrane filter with pores small enough to remove the salt and other impurities. Fresh water gets collected and waste is flushed away. So again, through this process, you're kind of forcing the salt and other things out of the water, and you're keeping that fresh water that is needed. Problem with this, though, is that it costs a lot of money and it costs a lot of energy. By taking away the salt water, you're killing a lot of marine organisms that live in these salt waters. And you're going to be producing a huge quantity of salt waste that requires proper disposal. It just can't be dumped back into the ocean. Again, you're going to be changing the concentration of salt back in the ocean. So the big thing is that you need to be smart about displacing it. And as you know, sometimes we're careless when it comes to where we displace different things. And so that'll conclude 10.2. Make sure you finish your notes for this section.